During the late 19th century, it was widely accepted in the astronomical community that Mars had life-supporting qualities, including the presence of oxygen and water. However, in 1894 W. Campbell at Lick Observatory observed the planet and found that, if water vapor or oxygen occur in the atmosphere of Mars, it is in quantities too small to be detected by spectroscopes then available. That observation contradicted many of the measurements of the time and was not widely accepted. Campbell and V. M. Slipher repeated the study in 1909 using better instruments, but with the same results. It wasn't until the findings were confirmed by W. S. Adams in 1925 that the myth of the Earth-like habitability of Mars was finally broken. However, even in the 1960s, articles were published on Martian biology, putting aside explanations other than life for the seasonal changes on Mars. Detailed scenarios for the metabolism and chemical cycles for a functional ecosystem were being published as late as 1962. The current understanding of planetary habitability, the ability of a world to develop environmental conditions favorable to the emergence of life, favors planets that have liquid water on their surface. Most often this requires the orbit of a planet to lie within the habitable zone, which for the Sun is estimated to extend from within the orbit of Earth to about that of Mars. During perihelion, Mars dips inside this region, but Mars' thin, low-pressure atmosphere prevents liquid water from existing over large regions for extended periods. The past flow of liquid water demonstrates the planet's potential for habitability. Recent evidence has suggested that any water on the Martian surface may have been too salty and acidic to support regular terrestrial life. The environmental conditions on Mars are a challenge to sustaining organic life. The planet has little heat transfer across its surface. It has poor insulation against bombardment by the solar wind due to the absence of a magnetosphere, and has insufficient atmospheric pressure to retain water in a liquid form. Water instead sublimes to a gaseous state. Mars is nearly, or perhaps totally, geologically dead. The end of volcanic activity has apparently stopped the recycling of chemicals and minerals between the surface and interior of the planet. In situ investigations have been performed on Mars by the Viking landers, Spirit and Opportunity rovers, Phoenix lander, and Curiosity rover. Evidence suggests that the planet was once significantly more habitable than it is today. But whether living organisms ever existed there remains unknown. The Viking probes of the mid-1970s carried experiments designed to detect microorganisms in Martian soil at their respective landing sites and had positive results, including a temporary increase of CO2 production on exposure to water and nutrients. This sign of life was later disputed by scientists, resulting in a continuing debate, with NASA scientist Gilbert Levin asserting that Viking may have found life. Tests conducted by the Phoenix Mars lander have shown that the soil has an alkaline pH and it contains magnesium, sodium, potassium and chloride. The soil nutrients may be able to support life, but life would still have to be shielded from the intense ultraviolet light. A 2014 analysis of Martian meteorite EETA 79001 found chlorate, perchlorate, and nitrate ions in sufficiently high concentration to suggest that they are widespread on Mars. UV and X-ray radiation would turn chlorate and perchlorate ions into other, highly reactive oxychlorines, indicating that any organic molecules would have to be buried under the surface to survive. Scientists have proposed that carbonate globules found in meteorite ALH 84001, which is thought to have originated from Mars, could be fossilized microbes extant on Mars when the meteorite was blasted from the Martian surface by a meteor strike some 15 million years ago. This proposal has been met with skepticism, and an exclusively inorganic origin for the shapes has been proposed. Small quantities of methane and formaldehyde detected by Mars orbiters are both claimed to be possible evidence for life, as these chemical compounds would quickly break down in the Martian atmosphere. Alternatively, these compounds may instead be replenished by volcanic or other geological means, such as serpentinite, impact glass, formed by the impact of meteors, which on Earth can preserve signs of life, has also been found on the surface of the impact craters on Mars. Likewise, the glass in impact craters on Mars could have preserved signs of life, if life existed at the site.